Yo, what is good, chat? How we doing? Oh my goodness, it's been a minute. I know. Sorry to blind y'all. I'm trying to make it to where y'all can see the chat. But I'm so glad you are doing good, chat, because I have been studying for this exam, this mechanical FE exam, and that is what we're gonna be doing the little YouTube video for. So I'll be recording that using Twitch and all that. So hope y'all can join me while I do that. And then let me fix this chat. Did y'all hear that? Let me fix the chat. Is there a way to edit the link though? You know what I mean? Because y'all can see it now. Right? I thought the chat was white though. Like the letters. Am I crazy? Like, yo, can y'all help me? My voice on the mic is so soothing. Thank you. Oh my goodness. Do y'all think that? Oh shoot. But anyways, so I've been studying for the FE exam, and to do that I've been using Google Classroom to sort of keep me organized and all that. So if y'all want a video on that, let me know. I can definitely do something that so y'all can work on your goals. So basically, I'm trying to be an architect. So I'm taking the mechanical FE and then the civil FE so that it can get me closer. And then I'm gonna just collect some certifications, and I'm gonna be recording it along the way. So hope y'all can stick with me. And that's what I'm gonna be recording these videos on. And if y'all want to learn something, we can with each other and all that. So. And y'all could even try taking the exam yourself, but you know. Anyways, let me try and fix this. I'm gonna be right back. we're back, chat. So, following the schedule that we have on Google Classroom, this week we're talking about some calculator tips, mathematics, and probability and statistics. So, basically today we're gonna go over. I want to go over some things that you can and can't do with your calculator, and with this we're gonna cover some common tips and problems, and then there are some problems where you can't rely on the calculator. Like, you actually have to know how to set it up for it to make sense and for it to work. And then there's some other topics that I personally had to go back for while I was studying and working through the problems that I have. And those are the topics that I had to go back for. So those are worth a little more of your time when you're studying. So let's go to the beginning of calculator mastery. So if y'all don't know, for the exam you gotta have this specific calculator that they have on their list. So let me see if I can pull up the link to where it is that you can see which calculators you can get. But I highly recommend the TI-36X Pro, just because it's like that's what you can do a lot of things on, like vector math, matrix math. You can do derivatives and integrals on those. So it's more suited for what you need, I would say. Here's the video I watched. So you can see how I hold up. Let me show you on my screen. So this is sort of how I set it up in my Google Classroom. I have all the topics here, and I have like down here like the topics. So all the topics here, I went ahead and made like little entries for them, and I found a video, and then I just auto-generated some problems based on the topics. So I just like said, hey, ChatGPT, give me some questions to hit these topics, and then I put them all into a little document so that we can work on them as we go. And then, so let's look at the kind of calculators that you can have. This is the YouTube video that I would put up there, so as my lecture. And Mondays and Tuesdays is when I do like note taking from these lectures, and then Wednesday and Thursday is when I work on the problems. So I usually have 2 topics a week, and then from there I'll be prepared for the FA exam, hopefully. And I have it on my calendar of all the topics, so I by myself. So these are the topics that we're going over. But does he say? No, he doesn't say. Hold up. He doesn't say where the thing is that you can see which kind of calculator that you need. Hold up. So I'll show you here. So I'm on the FE exam site where you can sort of look up everything. So licensure, why licensure matters, you can see like professional engineering surveying licensure provides public protection, safety of buildings, bridges, roads, and other structures and technologies used in our everyday lives depends on licensed professional engineers. and have successfully demonstrated a level of competence through education, experience, and examination requirements. These three E's are an important distinction between highly complex technical professions such as engineering and surveying and the trade and vocational occupations. So, FE exam. Let me see. So this is what we're looking at. So it's 110 questions, and it's 6 hours long. Calculator policy. So these are the calculators that you're allowed to have. Let me screenshot this. But no others. So this is the one I have. But yeah. So make sure you have that calculator. So, basically, for calculator mastery, the things that you can do in your calculator, you can find the roots of polynomials. So, the topics that like you can do that cover this are polynomial roots, variable storage, numerical integration, matrix inverse, matrix multiplication, determination, vector magnitude, dot product, cross product, complex operations, converting to polar form, polar for operations, and solving system of equations. So all those topics you're gonna have to like know how to do on your calculator, and it will help you in other problems, not just the math section, but like the physics sections and the like thermodynamics and stuff. It's gonna those sorts of problems are gonna help you there as well to understand the concepts. But these things will help you like knowing how to use your calculator, like it'll help you get through the questions quicker as well. So, and it is very important to know how to store your variables because that will help you. Like, if you know, if you are trying to get through a problem and you're having to type a lot of uh, variables like over and over again, like just store it in your calculator. And then, so find roots of polynomial, the things that you can do with your calculator. Finding the roots of polynomial. So you'll might see this in a problem where you have like area enclosed between two functions, and then variable storage, like I said. Matrix math, so matrix inverse and determination and doing like math and stuff. You can do that in your calculator. It's simple, like math, matrix, edit, put it in there, and then load it, and then let it do the math for you. And there's little different math things that you can do. And then numerical integration, you can do that on this calculator if you have the values, the boundary values and the x value. And then you can even do vector math, same way, same sort of feel for how you do the matrix math, but you just do it in vectors because, I mean, vector is just a matrix, and then you have all these different types of math that you can do with those vectors that you store in your calculator. You have like dot product, magnitude, finding the scalar product, and the cross product, so you'll need those in your physics equations as well, so it's very helpful to know. And then complex expressions, so this is like with your I and your like non-real or imaginary values. I mean, what am I trying to say? Your imaginary values. So, and you can put those in polar form and take those out of polar form and know how to work with both. And then solving the systems of equations. There's like literally buttons on here where it'll just solve the equations for you. All you have to do is put in the correct like values for things, and then it'll just solve it for you. And there's also some probability things that you can do in there too, but we'll talk about that later. So in the math section, the things that you can do on your calculator, just a little recap. You can do matrix algebra, root solutions, vector analysis, unit conversions, and built-in functions. So let's see. Some common problems that also you can do in your calculator. Let me see. That you don't really need to like look too much into. You just gotta figure out the little calculator combos. So one of them is like the distance formula. So you'll have to know how to use the distance formula and how to set that up. But I'll talk about some other things that you will have to know how to set up later. So distance formula is one of the things that you'll need to know how to put in your calculator. So that's, your square root of the x2 minus x1 squared plus the y2 minus y1 squared. And then that's your distance between 2 points. And then also you can do like log math in your calculator. So remember your log base 3. Like if you have 2 logs that's the same base and you're adding them together, then you just, what is it? You just multiply or divide the what's inside the parentheses of the log. There's some things where I had to like go back and look up, and I'm like, ugh, I forget about those logs, bro. But you just gotta refresh your memory, really. And the rectangular chords and the polar chords, you can put those in your calculator real quick and convert them. Let's see. I think that's pretty much all the things that you like can just straight up put in your calculator. And of course, like the matrix stuff, like angle between 2 vectors, you can do that in your calculator, and determinant of matrix. You can also do linear regression, so getting into the probability and statistics. Linear regression, like you'll mostly just have to put in the values and then do the system solve sort of thing, like I was talking about earlier. And you can do binomial distribution in it, and it has like specific functions for those system solve things. So if you're looking for matrix stuff, go to matrix. If you're looking for vector stuff, go to vector. If you're looking for like the probability, I would say go to the stat region, stat reg / distribution on your calculator. And then for system solving, there's a system solve button, so you can literally see it on there, as you can see here. But yeah. Okay. So you can do things like need probability of success, probability materials fail, using that binomial CDF and the binomial PDF math buttons, little functions, built-in functions, that's what they are. And then like putting the n number of trials and whether it's pass or fail, and then the percentage, and finding at most and at least things. So there you go. Those are the things that you can do on your calculator for the most part. So as a little recap, you can do some of those simple probability and statistics problems, and then you can do the matrix algebra, root solution, vector analysis, unit conversions, and built-in functions like with those. So some of the things that you should know how to set up, at least, I would say. So like these are the things that you gotta know how to set up, or you might make a mistake in the calculator. Even if you like put it in the calculator right, setting it up can be like devastating, you know what I mean? Like it could just setting it up wrong can make little mistakes. So that would be like point slope formula. Like you need to either sorry, lost my train of thought. Yeah, you gotta know like the little formulas, like y minus y1 equals m times x minus x1. You gotta know that formula. And then the distance formula, I would say you should know, and how to use it. And then equation for a line. So this is a really easy one. You just need 2 points or 1 point and a slope, but you'll have to know how to set that one up. And then another tip is to get everything back to sine and cosines whenever you're working with your trigonometry stuff. And then again with the logarithms, it's just like an exponent written in another way. So that's another tip for those sorts of problems. And remember your trig identities. And then in the tips for still looking at like common tips and common problems for math that you need to know how to set up is like these problems where it's like value of x less than 360 that will satisfy an equation. So you're sort of looking at the angles now, and the sines and cosines, those are a little tricky to think about. And don't forget to use your u sub. So if you look at a equation and it's asking you to like take a derivative, you can always use those u subs to help make it easier. Like with the sine, that's usually what you would do. Like this one has sine squared x. So you sort of have to know, be familiar where to look out for those things. So when you see sines and cosines, just be a little more careful and more what's the word I'm looking for? Analytical? I don't know. More in depth. Just be careful. And then know what the graphs looks like for sine and cosine. So sine starts at 0 and oscillates, and then cosine starts at 1 and oscillates. So at the peak, so at pi over 2 is when sine is 1, and then 0 is when sine is 0. And then when cosine of 0 is 1, and then cosine of pi over 2 is 0. If that makes sense. So they're like sort of opposite. Just remember, sine is even, so it's going to start on 0. Because 0 is an even number. Right? I think so. Okay. Because I struggle with like the sine stuff. It's just, I don't know. But luckily you can do the rectangular chords and polar chords in your calculator, so just remember those. And then SOHCAHTOA. Remember your good old friend SOHCAHTOA. And go through the motions. Like, don't skip steps, even if you're like working on it and you're feeling a time crunch. Like, I don't want you to skip steps, because that's where you make little mistakes. Like, you gotta write everything out so you understand it. Like, especially with SOHCAHTOA, like, even if you have to draw like an A and an O and an H to help you, and draw little arrows for where the angle is, I would do that. And make sure you use the book as well. There's certain equations for like circles and things. So let me show the handbook. So you can go over here to the outline and then go to mathematics. And say we're looking for the equation of a circle. Now these are ones I had to go back and look at the notes for. Like, you gotta refresh your memory on all this for real, or else you'll make little mistakes. But you know how to do it. Like, you gotta trust your education as well. Let me try to find the shape. So as you can see, all the things I've sort of talked about, like uh distance formula is right there, roots is right there, but your calculator can do a lot of it. Quadratic sphere, logarithms, base to another, identities. So when you know the stuff, it'll make it easier to be able to read these and use them. So you can't just like you just use the equation and the pattern. You also have to look at how to go from start to finish for what it's asking you for, and how to approach it, and how to like go step by step so you don't make mistakes, and you just know how to apply the equation. Like, you got to know where in my beginning in the equation, where do I need to end, and how do I get there, and what equation can help me with it. So that's the sort of thing. But you also got to set it up to be able to use the equation, if that makes sense. I think understanding the problem is like 50% of the game, and then the other 50% is actually solving it. And then here's your little polar coordinates, Eulers, roots, your trig, so your little SOHCAHTOA identities, and then you have your volumes. Let's see, these are the shapes. So sphere, wait, let's go back to the circle. Where's the circle at? Here it is, case 4. Center at HK is the standard form of the equation with the radius. So if you're ever trying to find the center, you can just put it in this form and extract it. So there you go. And then slope of curve. Oh. The slope is the derivative. Remember that. And L'Hopital's rule. That is when you're given like a limit problem. Remember L'Hopital's rule. So that's where, like, if it's 0 over 0, you just take the derivative. And then what else do we have? Total area over a region. So if you're faced with like total area over a region bounded by x axis and curve y equals sine x on the internal interval between x equals pi over 2 and x equals 2 pi. What the heck does that mean, right? Yeah, I don't know. That's where it really comes in handy to know what your sine and cosine looks like. Hold up. So right here, so sine starts at 0 and it oscillates. And remember, pi over 2 is right in that middle. And you're trying to find pi over 2 to 2 pi. Well, 2 pi is just the whole number. And so it's just 1, 2, 2 oscillations. So 1, 2. It's actually 1 oscillation, but the second half of it. Right? Because this is 1 pi, this is 2 pi, and there's a half. But you got the pi over 2, and so you go pi over 2 to 2 pi. And that's your little boundary, and you're trying to find that area. And remember, area is just taking the integral. So slope is derivative, integral is area. Then remember your general solutions to your differential equations. This is also one of the things I had to go back for. But I just wrote on a little sticky note, like, the different scenarios. So there's this scenario if the a squared is greater than 4b. Hold up. Let me see if I can see it here. So here's your L'Hopital rule, integral calculus, and your derivatives, your integrals. Let's look at the differential equations. Here they are. So what is a squared? A squared, if you put it in standard form, it would be so like the y double prime minus the y prime plus the y term, and you just turn that into a quadratic basically whenever you see that. And that's for second order differential equations. And then for the first order differential equations, hold up, I don't see it on here, so I'll have to go back to it. But second order, you just turn it into a quadratic and basically solve it. And then from that, you can get the 4b and the a squared. And then you have the case where you can find roots and they're different. And that's where you do the constant e to the whatever your root is times x to the exponent. So the exponent is your root 1 and x plus c2, so whatever that constant is, times e raised to the whatever your second root is times that x. So it's right here. And then if a squared is equal to 4b, then you have to put an extra x in front of this e. So you have x to the root and then 1 without the x to the root. Where's that at? I don't see it on here. Is this it? I don't know. And then if you have imaginary roots, that's when you gotta use the sine and cosine. And then see right here. Here it is. You gotta use sine and cosine. And so you're gonna most likely have it in the form of non-imaginary plus imaginary. So the imaginary part, let's see. Oh, it gives it to you right here. But I think it's like the imaginary part goes here and the non-imaginary goes here, something like that. I don't know, I'll have to find a problem later. And then the three vectors, just know how to set, like, with the IJK stuff, know how to use those cross products in your calculator. Yeah. What else do you gotta know how to set up? So you gotta know how to set up for the probability and statistics section. You gotta know how to do normal distribution and know the differences between all those distributions and things. So, like I said, I had to go back and watch a video for first order differential equations. So even though I did already watch the note videos, I was like, okay, I gotta go back and watch another video so I can understand this. So don't be afraid to go watch another video while you're doing your problems, just to understand the concept better. And then so the way to approach first order differential equations is writing it in standard form first. So that standard form is right here, as you can see. So you got that y squared plus, oh wait, this is second order. Oh, here it is, first order. So y prime plus ay. So this is one thing, this is another thing. And then, so now you know these, the a and the o. And so for the integrating factor, it is e to the derivative of whatever a is. So derivative of a goes here. So that's your integrating factor. And then for the general solution, you have to do the y equals 1 over that integrating factor times the integral of the integrating factor times whatever this 0 term is plus c. So you add that constant at the end. Like, it doesn't really explain it well in this. Like, this is sort of hard to understand. But this is what you'll need. So that's sort of how you gotta solve it. It doesn't really say that in there. But if you needed to know that constant integration or that constant, then you would have to know how to set it up. So, and then for second order, we have the p of x, or the y squared plus y prime plus b of y. You basically just put it into quadratic formula where it has the r squared plus r plus b. And then the general solution, so like I said earlier with these, you find that whatever this term is, you basically try to factor it, is what it is. And if you can't factor it, then you gotta use this. And then basically what it comes out to, if you have if you have multiple solutions, this is what you should get. And they're both positive, you should have this. Or both non-imaginary, both real. 2 real roots, you'll get this. 1 real root, you'll get this. And then imaginary roots, you'll get this. But you'll have to know that by setting up the quadratic formula. And another one is the initial value problem. So that goes back to the first order differential equations. Is you'll be given like this, and then y of 0 equals like 4. You'll have to plug back in for those. So you'll get to your general solution. So remember, you put it in quadratic formula, and then you factor it, and then whichever one you put it in that solution, that general solution, and then it looks like let's see. Then you use those initial values to find C1 and C2. So you'll get your general solution, and then so for those plugins, you gotta let y equal whatever it equals to, and then whatever it has in between the parentheses, that's your x. So you plug those into the equation, and from that you should be able to find C1 or C2, and whichever one you don't find, you basically take the derivative of it and then use that to find the other one. Alright, so those were the ones that you really had to know how to set up, and that I also had to go back for. So let me just go back through the ones that I said that I had to go back for. So I had to go back and look at how to factor again, because sometimes that can be a little tricky, and I know there's shortcuts to it. So basically, to factor it, you can use a quadratic formula, which is usually the quickest way, but you can also do like factoring where you try to have two numbers where it multiplies to give you C and then adds to give you the B term. But if you have a coefficient as A, then it's a little harder to do, but you still can do it if it's like smaller numbers. And then another thing is taking the chain rule. Chain rule is kind of tricky sometimes, so just remember it's the derivative of the outside times the derivative of the inside. So you take the derivative of the outside function, you have that, and then you times it times whatever is on the inside function. So if you take the derivative of sine of 5x, you take the derivative of that sine, which would be cosine, and then you of 5x, and then you take the derivative of that 5x, which is 5, and you just multiply that to that cosine of 5x. So then you get 5 cosine of 5x. And then I also had to go back and look at partial derivative of a function. Partial derivatives are tricky. It's basically where you just pay attention to one, you just pay attention to one variable, and then you treat all the others as constants, which that one can be a little mind-boggling. What else? So I had to go back and look at those. Normal distribution, I had to go back and look at. There's some formulas for that, like the between and like standard deviation and average. You just gotta know what those are. And then the difference between the distributions, statics and norm distribution, first order differential equations. I had to go back to. So make sure you look at these like a second time, like, oh shoot, because I think they're worth looking into a little bit more than initial value problems, because those will definitely be on the test. Boundary problems, Newton's method, Taylor and Maclaurin series, power series, Taylor series, linear regression. So for mathematics, I went through first and second order differential equations, initial value, boundaries, Newton's method, and Taylor and Maclaurin series. And then probability and statistics, I did linear regression, which would be like mean, and also mean mode and median, and then distribution. So there's binomial, normal, continuous, and discrete. And probability equations and tables, you can use those. So yeah, that's sort of the rundown. We can go through some problems real quick. I have some answers that I have. I don't know if they'll be correct, but we can work through some of them together quickly, and I can just look over my notes while we're doing this. So let me open up the Google Classroom and just show you what I have. So this one, the mathematics problem one, is like a little quiz, but these take longer to make, so I just stopped doing it after the second one because it took way too long to make. So I just made like a Word doc. Oh, hold up. So as you can see, I'm looking at these quiz problems, and I've already did them, so we can go through them. So the distance between the points. So these questions are definitely on the FE exam. If you want a good resource to see like sort of questions on the FE exam and an all-in-one book, this is the book I have. FE Mechanical Prep Exam Prep Material Book, whatever, as all kinds of practice problems. And this guy has a YouTube channel, and you can scan that QR code. And then he makes all the videos and stuff too. And I have some of his videos on here. But anyways, let's work through the first problem. So, finding the distance between 2 points, you just put that in your calculator really with the distance formula. So you'll have square root. So second, it's above the x squared button. And then parentheses, x minus x1. So you'll do 3 minus negative 5. And then you hit the x squared, you close the parentheses, and x squared plus the y minus y1, which is -2 minus 4 squared. And then hit enter and you get 10. 10 is what I got. Is that what you guys got? Great. So, equation of a line. Find the equation of the line passing through 2, 5, and 6, -3 in slope-intercept form. So, all you need to find the equation of a line is either 2 points or 1 point in an equation. So this is 2 points, so all you gotta do is find that slope with these 2 points. So you do the little fraction symbol, and then you do the y2 minus y1 over x2 minus x1. So you can do -3 minus 5 over 6 minus 2. So I get -2. Is that right? I think my answer key is wrong. So I got -2 for the slope. So then you set up your equation of y minus y1 equals m times x minus x1. Alright, let me pull up the pull up this. And in the FE exam, you can't control F. I don't know who said that you can, but you cannot control F in the exam. So make sure that you know where things are and that you scroll quickly because you can't control F. You can't search for things on the FE exam. So, once this pulls up, oh, here we go. So you find the slope and then you use this formula. So we got the slope is -2. So this is your slope formula, and now we're going to use the point slope formula. So this is where you got to use your PEMDAS. So you would have y minus 5 equals -2x, or -2 times x minus 2, right? So then you just solve for the equation, get that back into the form that it needs to be in, and then so you distribute. So y minus 5 equals -2x minus or plus 4 because we have two negatives. And then you just subtract that 5, or add that 5, so y equals -2x plus 9. So that should be your equation there. Alright, determining the center and radius of the circle. So remember that radius question. We gotta go all the way to that circle that I saw earlier, that I found earlier. Oh, that's the probability stuff. We're just gonna do a couple of these. So circle of an equation, or circle equation. There's the matrices, vectors, numerical methods, differential equations. There's the statistics. But it's hard to find things when you're scrolling, as you can see. Second order integrals. I don't see the shapes. They're not loading. But basically, the equation is the x minus h squared plus y minus k squared equals r squared. So usually I would just complete that circle. So half of your -8, you put the x's together and the y's together from that equation over here. And you basically complete the square. So half of -8 is -4, and then you square that, which equals 16, and you just add on that 16, and then you add on 16 to the other side of the equation. Do the same for the y, and then you should get 4, -3. So you factor those once you get that, and it doesn't really matter what's on the other side. You just got to see those, the radius of the circle, what that point is, and that point is 4, -3. And then taking the derivative, just remember chain rule, power rule, multiplication rule. You can see those in the derivative section here. So just remember these and know how to use them and what they look like and everything. So let's see, like this one, this would be your multiplication rule right here. And then, but taking the derivative is pretty straightforward. Optimization. This one, you basically have values. You give variables to the values that you don't know, and then take the derivative, set it equal to 0, and then basically the square maximizes the area. And then remember how to do your definite integrals, partial derivatives, double integral, first order ODE, second order. So that's basically what I went through. And then pseudocode. An error propagation is pretty simple. Taylor series I had to go back for. Pseudocode and logical development. Bro, I don't know. These are just like, start with this, input this, count this, sum this, print it, and then end. And then there's some things where you gotta find the rate, and then while it starts up until it goes to 1,000, and then you do these equations, is basically what it is. So basically, what would you type into MATLAB for it to do the math for you is what pseudocoding is. And then the flowcharts, I don't know, I think there's like some flowcharts in here, but I wouldn't pay too much attention to that. It's pretty, just go with your gut sort of thing. And then probability and statistics, I haven't finished all my problems, but there will always be time to go back. And I'm glad I reviewed with you guys, because this helps me too. I just hope it, you know, provides value to you guys as well, going through these things. And maybe you're not studying for the FA exam, but maybe you're studying for something else, and you can sort of see the way I go about it, you know, with my Google Classroom, setting it up all at one time, and then just doing a little bit every day instead of doing it, you know, big chunks, sort of do little by little, and then have big chunks where you review a lot of material. So that's sort of what I'm doing. So, there you go. Hope that helped. We can look at some of these probability problems too. So these things, I think I got up to this one. So I don't really know these ones. But I think these ones covered it mostly. I don't know about these ones. So I might have to go through those again. But I have a week of review and for missed questions, so I think I'll just go back and do these ones. I kind of want to play a game. Might play some Fortnite or some chess. What do y'all think? So let me... Yeah, I got up to question 7, actually. Question 7. Oh, no, I did question 8 too. Yeah, so I'm at question 9. Find least squares line for this. I think that you just put into the calculator. So that's an easy one. But I'm gonna staple these. And put them into my binder because we're not looking at these anymore this week. So next week we're going to be looking at economics and ethics. So it's going to be an easy week next week. Should just be some conceptual stuff. We won't have to do as much math, but we got the math over, so it'll help us later, and we'll see if we remember it in the statistics or statics stuff. So next week we're just doing these 2 topics. Yeah, I actually studied this I actually took it already and failed. So that's why I'm sort of going back and studying again. Because I now know, like, what to sort of look for. And hopefully I can do better on the next time I take it. So I'm sort of cleaning up my area, so I'm ready for next week to be taking notes on those things. And like I was saying earlier, there's some things that I want to get certified for. Like, let me read my list here, so I can get closer to becoming an architect. See, so when I doom scroll, I save things into like little sections, and then I try to go back and look for them. But you can't just keep making like collections. Like, you gotta have a stopping point, you know what I mean? And then, so that's how I got this list, was from those videos, from those Instagram videos. So they were all like, oh, if you want to get better in this industry or architecture or civil engineering, whatever, or better in this field, get certifications in these things. So my list is like Claude Code, Grab, CAD, Studly AI, Canva, AutoCAD, Bloom, Render a House, Revit, ArchiCAD, Twinmotion, Onscape, Photoshop, 3ds Max, PHUT, HuePrep, Civil 3D, ArcGIS, CSWA, CAD, Google Data Analytics, SolidWorks, Fusion, Parking Solver, Blender, Sims, SketchUp, Figma, GameTech, Manual, DS Render, Lumion, V-Ray, Illustrator, Corona Renderer, MIT OpenCourseware, Chief Architect, MicroStation, CapCut, Python, and also I want to take the bar. So that's the things, the applications I'll be learning probably in January. So for the rest of this year, I'm going to be studying for the mechanical FE and the civil FE, and then I will be attacking those certifications, and we can probably do those together. So as well. So if you're on a journey like me, or if you need to learn some of these subjects, then you can do that too and review it with me. Hopefully this helps. I don't know. I'm just sort of yapping. I'm not really going through any problems, but like these are sort of things you need to be aware of, I guess. I mean, we could watch some videos, but I feel like that's like things that you can do on your own time is watch the actual videos, and this is like sort of my preamp for you to get organized and see like which ones you need to focus on instead of just saying like, oh, focus on the biggest sections. Like you gotta understand like the mathematics section goes into the other sections as well, and then just hitting all the points on all of them. And so hopefully this is a review and an organization tip. Hopefully it's helpful. And also I'm sort of trying to get further my career and everything as an engineer, and I'm sort of documenting it, and maybe it can help me in the future as well. But dang, I just yapped for like a whole hour. So do y'all want to play something? I kind of want to play a game after doing all that yapping. Should we play some Fortnite? Do y'all want to play some Fortnite? Or we could play some Marvel Rivals. No, I should probably get off and not stream it because it's gonna glitch out. If it starts running bad, then I'll end the stream. But let's see if anybody's playing. Hold up, I'm gonna change the stream name, and then I'm gonna go use the restroom and get a snack, maybe. Hey, I'm back. Oh, I forgot to get a snack. I'm back. I'm gonna go get some fudge. I think it's coffee flavored fudge that I got. It's pretty good. All right. Pretty good. I ain't got nobody to play with. Who's this? Is there a proximity chat one? Or should we just like random queue squads? Let's do that. Oh wait. Let me see. Phil. And then 0 build. And then we're Lisa Simpson. Yeah, Battle Royale. I ain't got no Sprite to equip. Y'all been playing Fortnite lately with all the sprites? Is my like camera like huge? Or no? Is that better or worse? I feel like you can't see me though, is the thing. I think it looks cute like that. Then we have our little daily stuff goal. We got 1 from Rogue. Thank you so much, Rogue. Excuse me. Oh, someone followed me yesterday. NGT Spider. Thank you so much. Got my little saxophone. You know, I used to play saxophone in middle school. I mean, in high school. And I played flute. Is it running well? I can't tell if the stream is running well, so we chillin'. Maybe I'll join Discord with my friends. See what they're doing. I just be going wherever I haven't been for real. There we go. Hello? I got a ducky! Where'd y'all go? Oh shoot, I got a team on me. My eyes are burning. That was scary. That bleach guy almost got me. I'm trying to run away because I'm trying to get back to my team. Dang, they're all right there. I think it's a bot team though. I ain't got no good gun to shoot him with. Like, I ain't got no AR. Yay, they picked me up in the car. Alright. I'll catch y'all later, chat. Thanks for joining. Thanks for watching me. I hope y'all have a great day. And I'll see y'all next time. Okay. Bye.